All right, for this question, it asks, according to the phase diagram, what point would represent the equilibrium between, in this case, it's asking for the liquid and the gas phase. In a phase diagram, the equilibrium is represented by the lines, and we're going to talk a lot more about equilibriums as we move into modules 4, 5, 6, etc., as we move into future modules. The equilibrium is when you have, in this case, the liquid and the gas phases in equilibrium with each other. Liquid is becoming gas, gas is becoming liquid. We call this a dynamic equilibrium. Again, we're going to learn a lot more about those in future phases. But part of that is just understanding when I look at a phase diagram, at the lower temperatures, I have the solid phase. At the higher temperatures, I have the gas phase, and the liquid is in between. Now, phase diagrams can be a lot more complicated than this. The lines can get a lot more complicated, but essentially, you should be able to identify fairly quickly where the solid, liquid, and gas phases are based on the temperature scale. Higher temperatures, you got gases as opposed to solids or liquids. So the line between solids and liquids and gases, that represents the equilibrium. And along that line, we do have point E. And so I'm going to answer this with point E. Point G is not quite correct because that's actually the equilibrium between solid, liquid, and gas. Between all three phases, that's called the triple point. Point D is called the critical point. It is the temperature above which you only have the gas phase, no matter what the pressure is. It's sort of, in a phase diagram, it kind of goes straight up from there. We also see an equilibrium between the solid and gas if the substance sublimes. Sometimes this is bigger, sometimes it's smaller, sometimes it's only at lower pressures. And then we have here, I'm going to put it in red, we have the equilibrium between solid and liquid. This is where solid and liquid are in equilibrium. That represents the freezing point, which is the same thing as the melting point. And so point B would be the equilibrium between solid and liquid. And we can identify the boiling point temperature, the freezing point temperature, the melting point temperature at any pressure by going to that line. So at 760 millimeters of mercury, this temperature, I didn't draw it completely straight, but you see what's going on. That temperature represents the, between solid and liquid, the freezing point or the melting point. At 700 millimeters of mercury, that point, that temperature represents the boiling point. If I use the word normal, the normal boiling point, the normal freezing point, that is defined at 1 atmosphere of pressure. And you learned from your module, probably in Gen Chem 1, that 1 atmosphere is equal to 760 millimeters of mercury. So since I have millimeters of mercury on my scale, I'd go to 760. There's 750. This would be 775. So 760 would be somewhere around there. I would accept a range of answers, as you saw on the practice problems, for a melting point or a boiling point under normal conditions. The normal boiling point, the normal melting point.